So what is a random variable? It is a variable that has to take on numerical values, can't be categorical, and all the probabilities associated with the outcomes of the variable, they all have to add up to 1, and none of the probabilities can be negative, no probabilities can be greater than 1. Let's suppose you've planted 4 exotic plants at 4 different locations around town, and these are the probabilities. X, the random variable, is how many of those 4 plants are going to survive and do well. And these are the probabilities then. The highest probability is that 2 out of the 4 plants will succeed. That's 40%. Notice all the probabilities add up to 1. Okay, well now we want to find, let's say we want to find the probability that X equals 3. What's the probability that we get 3 successes? Oh, just right there, 0.15. What's the probability that X is less than or equal to 3? That means we could have 0 or 1 or 2 or 3 plants make it. So we add all those up, and that would give us 0.95. Hopefully you see the quickest way to get that is just to realize you can do 1 minus the 0.05, the only thing that can't happen. So that's how random variables operate. They take on numerical values. But sometimes it's number of successes, sometimes it's something else. Let's suppose that we're going to pay $500 for every exotic plant that thrives, that survives and makes it. So now we could state that instead of the random variable being the number of successes, we could say that the random variable is now how much money you're going to make. So if none of them survive, you make $0. If 1 survives, you get $500. If 2, it's $1,000. If 3, it's $1,500. And if it's 4, it's $2,000. So now the random variable is how much money we're going to make. It's still numerical, and it's still based on these same probabilities right here. A lot of the problems you're going to see on my assignment and perhaps on an AP exam is that you're going to be given a game that involves rolling a die. Let's suppose we know that the outcomes on a die could be 1, 2, 3, 4, 5, 6, and the probabilities for each would be 1/6. And so what we could do is we'd say, well, all right, this would be the probability distribution that for the number rolled on a particular die. But what if instead we played a game where we said, well, you know what? If you roll a 6, you get 10 points. If you roll a 5, you get 5 points. And if you roll anything other than that, you get 0 points. Well, now the random variable takes on the points that are assigned. And so now all of these simple events would combine to give you one event, and that is that a 0 points would be earned, and that would be a 4/6 chance of that happening. The probability of getting 5 points would be 1/6, and the probability of getting 10 points would also be 1/6. So yes, you did need to know about the outcomes on the die, but to get probabilities. But once you change things to a game involving points, the random variable is no longer the outcome on the die. The random variable is the points associated with each outcome on a die, and so you would construct your random digits table this way. So, and then also on the video and in some of the more challenging problems involving 2 dice, just remember that how do you get a sum of 2? How do you get a sum of 3? Well, if you look at that lattice diagram, or if you can think about how to show what the sums of the dice would be, then how many ways can we get a sum of 4? We can get a 2 and a 2, a 1 and a 3, and a 3 and a 1 on the die. How many ways can you get a 5? You could get a 2 and a 3, a 3 and a 2, a 4 and a 1, a 1 and a 4. So when you're calculating, what's the probability of getting a number that's at most 5 when we're taking the sum of 2 dice, you're just going to have to stop and think about, well, how many ways can that happen? And the cool thing about dice would be that there's 1, 2, 3, 4, 5, 6 ways to get any number from 2 through 7, and then it goes back down again. The way to get an 8, there's 5 ways, a 3 and a 5 and a 3, 6 and a 2, 2 and a 6, and 4 and a 4. So it's back down to 5 ways, then 4 ways, then 3 ways. So it's a triangular shape right there. So anyways, you're going to need that for some of the more challenging probability